All right, folks, in this lesson what we want to do is we want to look at delta G whenever we are dealing with non-standard conditions or whenever we start in a standard state and then as soon as the reaction starts we're no longer at that standard state. And then what we'll end up doing is we will want to relate delta G to our equilibrium constant K. So let's go ahead and consider the situation. Let's say that our reactants start out with a concentration of 1 molar. It's at 298 K. So whenever we start out, we are at standard conditions. But as soon as this reaction starts, what we're going to see is the standard conditions are disturbed. So we're no longer at standard state. So what we actually need to do to determine the spontaneity is we need to determine delta G, not delta G standard. So what we'll see is we have an equation for this. We have delta G is equal to delta G standard plus RT ln of Q. So here, delta G standard, we could calculate that in either of the ways that we've explored previously. R is a gas constant. We use 8.314 joules per mole Kelvin. Our temperature is represented by T, but it has to be in Kelvin. And then finally, Q is our reaction quotient. So what we'll see is if Q is much less than 1. Okay, if Q is much less than 1, that means that this term RT ln of Q is less than 0 as well. So that means that the reaction will proceed towards the products, okay? Because we have primarily reactants. The other case that we may encounter is whenever Q is much greater than 1. And whenever Q is much greater than 1, it means that you have mostly products. And that means that this term, RT ln of Q, is much greater than 0. So then delta G would end up being greater than 0, and you would end up proceeding towards the reactants. So here, if Q is much less than 1, so if you have a very, very small Q value, delta G is going to be less than 0, which would indicate that the process will be spontaneous. And if Q is much greater than 1 or much greater than K, what we'd end up seeing is delta G is greater than 0, so this would be non-spontaneous. So the question now is, what happens if you're at equilibrium? Well, let's think about this. At equilibrium, we know the following. We know that delta G is equal to 0. And we also know that Q is equal to K. Since we know that, we can substitute into our equation, and we can say that 0 is equal to delta G standard plus RT ln of K. And if we rearrange this, we can say that delta G standard is equal to negative RT ln of K for standard conditions. And what we'll see is that for K, it will be Kp, will be used for gases. And that we'll use Kc, used for solutions. So we can actually go on to use this equation to determine from a equilibrium constant whether a reaction is spontaneous or non-spontaneous. And that's what we'll do in the next episode, is we will try a few sample problems together.